Okay, now we're going to see how we allocate an object, namely an object of type pacman. Here we have a class pacman. It has two instance variables, x and y, that's a position somewhere in the game. It has a constructor here taking two arguments and initializing the two instance variables. Then we have a class world with a simulate method. And our life here starts with a world existing. Here is our world object. And somebody calling the method simulate on this world. Here is the stack frame of this method invocation. So the stack frame holds parameters and local variables of this method call. So we're about to start to execute the simulate method. We have, as always with instance methods and constructors, we have a this in here. So this is an implicit argument for the simulate method, which points to the world object on which we perform our work. The first thing we look at now is which local variables and parameters the simulate method actually needs. So we can allocate space for them inside this stack frame. This is already given. Parameters, explicit parameters here, we have none. But we have one local variable, p, of type pacman, that is visible here, that we need to allocate. So let's add one reference variable with name p and of type pacman. Here we are. So that's what happens with this first piece here of the first statement. We say we have a variable, a white box, which may one day point to a pacman object, but right now there is no pacman object yet, and the variable points nowhere. It's null. Now we're going to execute an assignment statement, and we'll actually store some reference in this variable. But before we can store anything, we need to create that thing. So here we're creating an object, new. And the object is of type pacman, and we're invoking a constructor here taking two arguments. Looks like two integer numbers. And if you go in the pacman class, we find there is a constructor taking an int x and int y. So that seems to be the constructor we're invoking. So we allocate an object and invoke a constructor, all in this expression. Let's first allocate the object. Create an object, we need to know the type, it's pacman. And then the object should contain instance variables or fields. If we look here, we see that we have two instance variables, x and y, in class pacman, so we need two of those in here in our object. So we have two. Now let's set up their names. This is x and this is y. And then let's set up their types. Both of them are of type int. So now we have two white boxes in which we can store integer values. They're part of our pacman. They define our pacman. Now we need to put in the initial values. Before we execute the constructor, those variables already contain some value. They're all initialized to 0. Now we have our newly allocated pacman, and we need to invoke the constructor, passing in 9 and 2. When we invoke the constructor, it's like calling a method. We need some space to store the local variables and parameters of this method, and that's on the stack. So here is our stack frame for this activation of the pacman constructor. So it's pacman.pacman taking two ints. This is our activation record. Now we need to say what are the parameters and local variables we need in here. Well, we see that there are two parameters here, two ints. But for a constructor, you always also have the this implicit parameter. So let's add this. This, and what's the type of this? Well, it's pacman. What are we constructing? We're constructing a Pac-Man. And then we have two explicitly given here parameters, x and y. So x and another one, y. And their types are int and int. Okay, clean it up a little. So we have an implicit parameter, this of type Pac-Man. Actually, that thing is initialized when the constructor is being called, and it points to the newly allocated Pac-Man object here. Then we have x and y, also those are initialized when Pac-Man is being called, namely to 9 and to 2. So 9 and 2. So now we are here. We are about to execute this method, this code inside the constructor, namely the first statement here. And this first statement is an assignment statement here with the equal sign. It evaluates this expression here and then assigns the result, the value, to this variable here. Okay, so let's evaluate this expression, x. Well, what's the value of x? There could be multiple x's. We see a variable called x up here, and we see another variable called x down here. This one is the closer one. It's immediately surrounding this statement here. And so that's the one we use. So we're going to take the value of this parameter, meaning we're going to take the value of this x. And if you look in the box, there's a 9. We take that 9 and we assign it to this dot x. So that's a different x. That's the x in this object. So that's this dot x. So this is the place we're going to store the number 9. This first statement now is complete. We can move to the second statement. We take the y from our parameter, value 2, and we assign it to this dot y. We store it in here. Now the second statement in our constructor is complete and the constructor is finished. When a method or a constructor finishes, we don't need the stack frame anymore and we can delete it. And we're about to return. So we just evaluated this thing and the result of this thing is actually a pointer, an arrow to this Pac-Man object. And what do we do here? We're assigning that to our local variable p. So the p gets assigned a reference to this Pac-Man object. So this is now the result. And we are done with this line here, with this assignment statement. And you now see the ultimate state of our system. We're still in the simulate method. We have two variables, the implicit this, which you don't see anywhere, and the p, which is declared here as a local variable.